Hi, it's time for another math easy solution. Today we're going to discuss further into approximate integration and now look at example 7, and it's again using Simpson's rule error. We're going to go over that. Basically this example states use Simpson's rule with n equals to 10, or this 10 subintervals, to approximate the integral from 0 to 1 of e to the x squared dx. And then part B says estimate the error involved in this approximation. So when solving this using or approximating it using Simpson's rule, let's first let's go to A, recall the Simpson's rule. So recall Simpson's rule, which is basically like I go over my earlier video. So we have this function. If you have f of x dx, this is basically equals to the Simpson's rule approximation, which equals 2 delta x over 3, and then you have f of x 0 plus 4 f of x, I'll go over here, 1 plus, then you have the pattern here, f of x 2, and etc. You keep going on and on until you get the last 3. You have right here x, this is going to be n minus 2, and there is going to be a 2 right here, it's plus, and then there's going to be a 4 fx and minus 1, and then plus the last one is just by itself, f of x n. And again, you get to go see the proof for this in my earlier video on the Simpson's rule and its derivation. So basically we have this, and in our case we have our f of x is going to be equal to e to the x squared that we are approximating, and the delta x is the width of the subinterval. That just equals to b minus a over n, where n is 10, and b is going to be our 1, and then 0, which is here, this is the left endpoint, divided by n, which is 10. So this equals to 0.1, so this be 1 over 10. So 0.1, and now if we just plug in these numbers, so we have our s of 10 is going to be equal to, plug this in, 0.1 divided by 3, and then we have this f of, I'll just put this here, it's going to be e to the x, x squared. In this case we have we have 0, x0 is 0, so I'll just write that over here. So we have x0 is equal to 0, and then x1 is equal to 0.1, x2 equals to 0.2, etc. Keeps going on and on until we have x9, which equals to 0.9, and then x10 equals to 1. So because it's just separated by 0.1. So the first one's going to be x0 squared, that's just going to be, well, all 1, plus, now we have a 4, e to the 0.1 squared, plus 2e to the 0.2 squared, plus etc. all the way. You keep following this pattern, and then we get right here, this is going to be 2e to the 0.8 squared, and plus 4 e to the 0.9 squared, and then the last one is e to the 1. And now before we solve that, just make a simple note on these calculations. So well, 0 squared, that just equals to 0, and that's just 0 times 0, 0. If we get 0.1 squared, this equals to, well, 0.1 times 0.1, which equals to, well, just move a decimal place to the right, so we get 0.01. And similarly, 0.2 squared equals to 0.2 times it by 0.2, which what you could do is take a 2 out, so this equals to, well, 0.2, and then we have right here, actually you could take it 2 out twice of it, this will just be, actually I'll just do this, 0.1, so we move this over to a decimal place and then just times it by 2. This just equals to 0.04. Similarly, 0.3 squared, this just equals to, well, 3 times 3, but then decimal place over there, equals 0.09, etc. all the way down till we get, let's say, 0.8 squared equals to 0.64. And then 0.9 squared equals to 0.81. And then the last one, 1 squared, that's just equals to 1. So that's just a note. So now if we put all this together, we have S of 10, or the Simpsons rule is 10 subintervals, equals to 0.1 over 3. Now the first one is e to the 0, that's just 1, plus 4 e to the 0.01, plus 2 e to the 0.04, and then etc. all the way until we get to the 2e. This is going to be 0.64 plus 4e 81, so 0.81. The last one is just e to the 1 is just e. Yeah, and here I've just quickly brought the full length of here just for completeness sake, so we get this 0.9, 0.16, 0.25, 0.36, 0.49, 0.64, and again there's this pattern of 424, 2424, etc. So now if we plug this into the calculator, so here I've plugged it in, I just used Google's calculator, I just Google search it, 0.1 divided by 3, and then times it by 1 plus 4e, then there's 0.01, 0.04, 0.09, 0.16, and if we keep going, there's 253649, 6481. So again, this 49 is 7 times 7, this is 8 times 8, this is 6 times 6, 5 times 5, 4 times 4, etc. And the answer is 1.462681. Let's just write that full thing down. So this is roughly equal to 1.46281. And this is our approximation for that integral. And now let's look at part B, which states estimate the error involved in this approximation. So let's do part B now. So part B, the error, first thing we'll do is recall the error formula. So recall that the error is written like this: absolute value of e to the s for Simpson's rule less than or equal to k times b minus a. This is going to be 5 divided by 180 times by n 4. Yeah, where basically k, alright, where k is, again, recall, it's just going to be equal to less than the absolute value of the fourth derivative of x, of f of x, for the domain x is less than or equal to 2, less than or equal to b, greater than or equal to a. So that's the formula for the error bound. So now in our case we have b equals to 1, a equals to 0, again n is equal to 10. So now our function f of x equals 2. So what we need to do first is solve for, well, this k value. Yeah, and where this k value is basically a number such that is greater than or equal to the absolute value of the fourth derivative of x for the domain x is less than or equal to b but greater than or equal to a. So in this case what we have, again, our b is equal to 1, a is equal to 0, and then we have n equals to 10. So our k defined, so we just need to find our k. So we know that the f of x, that's just basically e to the x squared. So what we have to do is solve for the fourth derivative. So we get f prime of x equals 2, well, using the derivative of this. The derivative of exponential function is just itself, but now we need to do the chain rule. So the derivative of the inside function, x squared, so that's just going to be 2x. And then we have to do the second derivative, do the same things, derivative of e to the x squared is itself, but now we have to do product rule. So we get e to the x squared, and then we have to do, again, chain rule. So then by itself, then the inside here, 2x, so that's going to be 2x again. So 2 squared, x squared, and then we have to do product rule. So the derivative of this, that's just 2, and then times it by this ex squared. So that's just the product rule. I'm doing this all in my head, so you should be able to do this if you're up to this level of this video. So now we need to solve for the third derivative. So now this third derivative, this is just going to be more tedious product and chain rule. So again, we take this first one here, ex squared. Derivative is itself, but then the chain rule, we put this 2x down with the derivative of the x squared. Since we have this already, this will just be 2 to the 3 x3, and then we have to add now the derivative of this using product rule. This is going to be, well, this 2 goes down, so we'll have a 2 to the 3, and then there's going to be an x, and then there's going to be a e to the x squared. And then now we have to look at this one right here, and this derivative of this is just going to be, well, 2, and then there's going to be e to the x squared, that's itself, and then using chain rule, this goes down, so we have this 2x times it here, 2x. So what we could do is instead just put the squared here, times by x, so just do that. And then the last one, the fourth derivative of x, this equals 2. Again, this is just more tedious stuff. So e to the x squared, then this is going to be 2 to the 4 because using chain rule, x to the 4, and then plus product rule, this 3 goes down. So we have a 3 times it by 2 to the 3 times it by x squared. When you minus it, then just put this over here for the product rule. And then plus, now what we have is this this part right here, derivative of this first one, that's just 2 to the 3 times it by e to the x squared. And now using product rule, we have to do the derivative of this part, and I'll just do that over here. So we have that is just going to be e to the x squared. Putting that 2 down, we'll have 2 to the 4, and then x, there's a, because it's 2x, x squared. And then we have the last part. Finally, we'll have 2 to the, so this derivative right here is just e to the x squared. Let's write that here. And then it's going to be, well, 2x, so it's going to be 2, 3 times by x. Put a 2 there, and then the chain rule. The derivative of this is just itself, and there's a 2 squared. And then this is just going to be e to the x squared. Yes, so now instead of trying to just simplify this all, just because all we have to do is find a k value that's greater than or equal to this derivative, or this fourth derivative. So what we have to do is note that this is always positive. So note that f4 of x, well, is positive, because when you put a positive number in here, there's nothing that's going to make it negative right here. It is positive for x is less than or equal to 1, greater than or equal to 0. So what that means is, well, it's positive and it's also is also increasing. Because as you could see here, when you put in a big number, when you put in, let's say, when you put in 0, you have a bunch of cancellations here, and then when you put in 1, it's gonna be the biggest number, because if you put in 0.5, there's fractions here. So as you can see, everything's positive and is increasing. So what that means is, all we need to worry about is that the value at 1. So means is if it's always positive and it's increasing, this means that our f of 4 of x, or absolute value right here, is going to be less than or greater than 0. So it's always greater than 0 because it's positive, and it's going to be less than, well, since it's always increasing, the last value here. And that's just simply f of 4, the derivative of 1. And that value right here, we could solve for it. So f4 of 1 equals 2. We'll just plug it in. Well, first let's just factor out all of these. So I'll factor this e to the x squared, and also this, another common factor, which is this 2 to the squared. So factoring that out, we have 2 squared times by e to the x squared. This is again just be tedious stuff, so factor all this out. we get 2 to the squared. There's an x4 right here, plus 3, then there's 2 times 2, and then there's an x squared, and then plus 2, then we go to here, plus, there's a 2 squared, and there's an x squared right there, and then plus 2 times another x squared, and then the last one is, this one's going to be 1, because that's what we factored out. That's all happens to be the whole thing. So we get all this, and now, just to make it a bit easier here, let's just factor out the 2 inside of this one. So we equal 2. I just want to do this by hand, so it'd be a good exercise in mathematics or algebra. So we have this, factor this 2 out for all of these parts. So we got a 2 here, and then there's going to be a 2 x4 plus, well, actually we could just plug in the 1. If we plug in 1 right here, these all just cancel. So all the x's is just 1, so we'll just remove that. So we'll just factor it out. So these ones, I'll say equals to 1. So factoring it out, plus there's a 2, so there's a 3. We factor this out, plus 1. This is going to be plus 2. This is 1. And then plus this 1 is by itself. It's not factoring that part out because it's just a 1. So what this equals to, this is a 2 plus 3 is 5, plus 1 is 6, plus 2 is 8, plus 1 is 9. So 2 times 9 is 18, plus 1 is 19. So this equals to 4, let's put that by itself, so ex squared. Now we have a 4 times it by, this is 18 plus 1, 19. So we could do multiplication by hand, or put in your calculator. I just want to do this by hand. So 4 times 9 is 36. Put a 3 above. 4 times 1 is 4 plus 3, 76. So this equals to, so this equals to 76, and then put in the 1 here. That's just going to be E right there. So this is just 1. Let's erase this. Put a 1. And this x squared, put in a 1. That's just 1. Yeah, so what this means is our k value is greater than equal to 76e, so we'll just pick 76 for it. Thus what we have is absolute value of the error is less than equal to, put the k, 76e, and then 1 minus 0 power 5, then we'll have 180 here, n, which is 10 to the 4. And then this equals to 76e, 180, 10 to the 4. And then plug this into the calculator. We get, plug this in, 76 times e. I've already done it on a Google calculator. Divided by 180 times 10 to the 4. You get 0.00011 and then 47. I'll just round up to 15. So this means is that the error, the absolute value error, is going to be less than 0.00015. And for completeness, I'll just write this one, if you put in a calculator, is roughly equal to 0.0015. I'll put that a bit neater, like that. Yeah, and thus what we have, basically what it means is we have corrected 3 decimal places because there's 0.00015. The integral from 0 to 1 of e to the x squared dx is roughly equal to, and then if you scroll back up, let's go back here, we had a bunch of decimal places here, so 146, and then rounded up 3. Yeah, so we rounded up, this is 1.463, like that. And now if we compare with example 3 on the approximate integration video I did earlier, you can see the video link below. I used the midpoint rule for the same integral and same function. The accuracy was only within 2 decimal places because the error was calculated to be less than 0.007, as opposed to this one right here, which is 0.00015. which is significantly less than this error. Anyways, that's all for today. Hopefully you learned from this video. And yeah, again, since it's slower than this one, this just points out how much more accurate the Simpsons rule is. Anyways, that's all for today. If you learned, like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.